Okay, this is the Unit 5 test review. I'm just going to go through a few problems off the review. So first, we're asked to write each expression in exponential form. So right now we have it in radical form. So you look at these radicals. They're in radical form, and we want to rewrite them as rational exponents. Rational exponents, which means fractional exponents. So remember our picture of our flower. Roots are on bottom, just like a flower, and then the power comes from the top. The sun is our power. So power on top, roots are on bottom. So that's the first thing to remember. So this is a square root, and it's base A. So we have base A, square root, so roots go on bottom. So if there's not a 2 written there, but remember that always means square root. So it's a square root of A to the 5th power. Now we didn't need parentheses around this one because it's only base A. There's only one base, so this would be our final answer. Now with this one we have to be careful. Is 10 and x both under the same root? And it looks like they are. They're both under the 6th root. Now ask yourself the next question. Is 10 and x both raised to the 5th power? And it is, because they're in parentheses. So we have base 10 and x, and we need parentheses around it. Since they're both under the same root, our 6 goes on bottom. And then our 5th power, they're both to the 5th power, so our 5 goes on top. Power's on top, roots are on bottom. So same thing here. We have base 5 and base n, and they're both raised to the 3. Power goes on top, and roots go on bottom. It's a square root, so it's a 2 on bottom. So those are our final answers there. And now we're going backwards. We're writing each expression that's in radical form in rational exponent form. So this should say, write each expression in radical form. So we're taking these that are written with fractional exponents, and we know that that's the same as a radical. So we've got to write this correctly. So the first thing to pay attention to is base 6 and base m both raised to the 5/2 power. Because of the parentheses, we know that they're both under the same root and they're both raised to the same power. So this is a square root. Now remember, square roots are always written as a blank root, but we know that's a square root. Now you have to put this 6m in parentheses, and they're both raised to the 5th power. Now understand that you could write it like this, the square root of 6 and m, and it's both raised to the 5th power. Either answer is equally correct, and you could see it either way. It just depends on the test, and it just depends on who's writing the test, but they are equal. Either way, the parentheses are correct in both cases, specifying that they're both under the root, and they both are raised to the 5th power. So let's look at number 6. We have 3n raised to the 7/4 power. They're both in parentheses, so they're both being raised to the 7/4 power. So they're both under the same root, and it's a 4th root. Make sure to write your 4 nice and pretty, tucked in there tight in that root. And then we've got to put parentheses around 3n to the 7th power. Now once again, it would also be correct to write it like this. The 4th root of 3n, and it's all being raised to the 7th power. Remember, roots are on bottom, power's on top. So that's how we know it was a 4th root and raised to the 7th power. Next one, we have a to the 5/2 power. This one's quite easy. It's a square root of a to the 5th power. And we're done. Okay, on this next part, it says simplify first using properties of exponents and then write in radical form. So remember, we're using properties of exponents when we multiply the same base. So looking at number 9, we have all this stuff being multiplied. Now with multiplication, since there's no addition signs and no subtraction signs, we can reorder it. So I like to put like things by each other. So I put 3 times 4. I'm just reordering it. I have a times p squared, times p squared, and then I have times p to the 3/2 power. Now from here, you're just going to simplify. So with numbers, we know we're just multiplying. 3 times 4 is simply 12. And then when we're multiplying the same base, and they're all p's in this one, when we multiply the same base, we add our exponents. So you take your calculator, do 2 plus 2 plus 3/2. You'll get a decimal. You get 5.5, and so you change it back to a fraction, and you get p to the 11/2. So we've done the first part. We have simplified, but now we're going to write in radical form. Now be careful with this one because 12 is not being raised to the 11/2 power. Only p is raised to the 11/2 power. So technically this is equal to 12 times 5p raised to the 11/2 power. So only this piece is going to get rewritten with rational exponents. So we have 12 times the square root of p to the 11th power. Now remember, the blank root is not a blank root, it's a square root. That's why technically there's a 2 in there, but we don't write it. This would be our final answer. With this next one, we have n to the 1/3 power times n squared. Now, when you multiply the same base, you add your exponents. 1/3 plus 2 is 7/3. You'll do your calculator, you'll get a decimal, change it back to a fraction, you get 7/3. So we have n raised to the 7/3 power. Then from there, we'll rewrite it with rational exponents. Roots are on bottom, so this is the cube root of n to the 7th power. Okay, the next piece says factor completely. The first thing we do is check, always with factoring, we always check, is there something in common we can pull out in all the terms? In number 11, nothing factors out in the beginning. There's nothing in common in all 4 terms. So we know if we have 4 terms, 1, 2, 3, 4, then we will always try factoring by grouping. You group the first 2 terms, group the second 2 terms, and you always group the sign with it. So then from there, you focus on each group and pull out what you have in common. The greatest thing in common. 6x cubed minus 6x squared. The greatest thing in common is 6x squared. So when we pulled out 6x squared, we technically divided by 6x squared from each term. So 6x cubed divided by 6x squared becomes an x. So left in that first term is x. Negative 6x squared divided by 6x squared doesn't go away, it becomes a 1. So minus 1. Now we look at the next group and we pull out what we have in common. Now don't say there's nothing in common. There's always a 1. And we're going to pull out positive 1. So then you'll divide each thing by what you pulled out. So we're dividing out a 1, dividing by 1. So then left is, in the first term is x minus 1. Now you'll check your safe haven. Safe haven is the exact same, sign and all. So the sign even has to be the same. And it is, so we're good. So we pull out the safe haven. So I pull out x minus 1. Now when you pulled out x minus 1, you were able to pull it out because it was in both terms here. So we pulled it out, it's right there, and then it divided out when we pulled it out. So left in that first term was 6x squared, and then left was positive 1. So plus 1. And this would be our final answer. Just make sure you check both your terms, both your final answers, and make sure it doesn't factor out any further. X minus 1 nothing comes out of that more, so you're done. 6x squared plus 1, nothing more comes out of that, so we're done. Next thing, number 15, we look at it. There's 4 terms. Is there anything in common we can pull out in the beginning? And the answer is no. And because there's 4 terms, we always try factoring by grouping. Make sure you group that sign. All right, so then in the first group, I pull out the greatest thing in common. The greatest thing in this one is an x squared. Divide each thing by what you pulled out. So 3x cubed divided by x squared is just a 3x left. And then x squared divided by x squared is a 1, so plus 1 is left. Now in this group, what's the greatest thing in common? Well, we're going to pull out a 3, and because of that negative, we pull out a negative with it. So we pull out negative 3. So you'll divide each term by negative 3 to see what you have left. Negative 9x divided by negative 3 is positive 3x. And then negative 3 divided by negative 3 is positive 1. Now you check your safe haven. Is it exactly the same? And it is. So I'm going to factor it out. So I factor out 3x plus 1. So when I factored it out, it divided out. And in my final answer, it's right there. And left is x squared minus 3. Then you check your answer to make sure that those don't factor down any further. And 3x plus 1, nothing more came out of that. X squared minus 3, nothing more came out of that. So we're done. Okay, factor completely. So with factoring, remember, we always check in the very beginning, is there something in common we can pull out? In fact, I want the greatest thing in common to be pulled out. So in number 17, I have 2 terms. The greatest thing in common is each term has at least a p cubed. So I'm going to write what's left in the parentheses after I took out that p cubed. So p to the 4th divided by p cubed is just a p. And then negative p cubed divided by p cubed is negative 1. So then from there, that doesn't factor further, that doesn't factor further. So that would be our final answer. N squared minus n minus 90. There's nothing in all 3 terms that can be factored out. So it looks like this is quadratic because it's degree 2. And we know how to factor quadratics. Remember that a is equal to, well, you'll look in front, a is equal to 1, b is equal to negative 1, b is in front of that, and then c is equal to negative 90. So we're doing what multiplies to be a times c, what multiplies to be a times c, and adds up to be b. So a times c is 1 times negative 90. What multiplies to be negative 90 and adds up to be negative 1? 9 times 10. Our negative has to be with our 10 because we need it to add up to be negative 1. 9 plus negative 10. It works in both boxes. So our factors are positive 9 and negative 10. Now you would look, is our a value 1? And it was. If your a value is 1, this can quick factor. So we know it's going to factor to be a binomial being multiplied with those two things. So there's an x plus 9 and an x minus 10. So we were able to quick factor this one, and that would be our final answer. All right, moving on. We have 3x squared plus 15x plus 18. Now, if you look at this, the first thing I always do is factor out the greatest thing in common. So in each term, there is a 3. So I'm going to factor out a 3. Now, what's left? Divide each term by what you pulled out. Left is x squared plus 5x plus 6. Now, don't stop there. Look at your inside of your parentheses. Can't you factor that further? Well, it's a quadratic, and we know how to factor quadratics. We do. What multiplies to be a times c, so that'll be, well, a is 1, b is 5, and c is 6. So we're doing what multiplies to be 1 times 6 and adds up to be 5. So, adds up to be 5. So it'll be 3 times 2, right? 1 times 6 is also, let's see though. To have it add up to be 5, we have to put a negative with the 1. And that won't work because negative 1 times positive 6 is not negative 6. It's not positive 6. That would be, these factors would be negative 6, and it wasn't negative 6, it was positive 6. So the only factors possible are positive 3 and positive 2. Now remember, if your a value is positive 1, you can quick factor. So we can quick factor. So this was 3 and 2, it works in both cases. So because we can quick factor, it's going to become a binomial with those two things. And it's positive 3, so a plus 3, and it's positive 2. So we're going to do a plus 2. Now don't forget in your final answer that you, in the beginning, factored out a 3. So we can't forget that that was there. There was a 3, then we factored it further and got a plus 3 times a plus 2. So this would be our final answer. Now there was another way we could have done this one. We could have done, and I'm going to do it the other way now really quick. So that is our final answer. We could have done it one more way. So we could have simply stated in the beginning, this is quadratic, so I can do what multiplies to be a times c and adds up to be b. So 3 times 18 is 54. What multiplies to be 54 and adds up to be 15. And that would be 9 times 6, and they're both positive, 9 plus 6. So it works in both cases, but we could not quick factor this one because our a value was a 3, not a 1. So we drop and break. So we're dropping down our n terms, 3x squared and positive 18. And then we break down our middle term. We're rewriting 15x as positive 9x and positive 6x. So then from there, we group the first two terms, we group the second two terms, and in this group, there's a 3x in common, so left is x plus 3. In this group, there's a 6 in common, in fact, a positive 6, so left is x plus 3. And then we have our safe haven, which is good, so we factor out x plus 3, so it divided out, leaving us with 3x plus 6. Now then you would look and say, well, do any of those factor out further? This one doesn't, but this does. We can pull a 3 out of this piece. So if I pull a 3 out, that would be x plus 2. So then we would write it pretty like, there was 3 times x plus 2, and then we had x plus 3. So they like to write the 3 in front just because it's prettier, so 3 times x plus 2 times x plus 3. So either way, you would have got the right answer. It's just depending on how you want to do it. Okay, remember with factoring, the first thing we check is there something in common right now that I can factor out of all my terms. So I look, there are 3 terms. Is there something in common in all 3 terms? There's an a. So I divide each thing by what I pulled out. So I pulled out an a, but I wrote it. Don't forget to write it. You pull out an a, you get a squared plus 6a minus 40. Now from there, you'll check your inside. Could I factor it further? And it's quadratic because it's degree 2, and we know how to factor quadratics. So we're doing what multiplies to be a times c, which is negative 40, and adds up to be 6. So we're going to think of factors of 40. So that'd be 10 times 4, 10 times 4. And those could add up to be 6. But it needs to be positive 6. So we're doing 10 times 4. It needs to add up to be positive 6, so it's going to be a negative with the 4. Now look, is your a value 1? Well, in front of a squared is a 1. So we know our a value is 1. So we can quick factor this. Now once again, this is 10 minus 4. So our factors are positive 10 and negative 4. And we can quick factor this. So it's going to factor to be a binomial with those two things. So it's going to be a plus 10, a minus 4. And then don't forget, this is the most common error, is that we factored out an a in the beginning. So that's part of our answer. So they'll usually write that in front. So a times a plus 10 times a minus 4. So this would be our final answer. Just don't forget the a, because that's a common error. That is our final answer. All right, in the next one, is there something in common in all three terms that can factor out? And there's not. But it is quadratic right now. So we can do what multiplies to be a times c. So what multiplies to be 1 times negative 27, which is negative 27, and adds up to be negative 6. 9 times 3. It needs to add up to be negative 6, so I have negative 9 times 3. And make sure it works in both boxes. And it does. Negative 9 times 3 is negative 27, and negative 9 plus 3 is negative 6. And then we can quick factor because of that a value, which means what's in front of x squared is equal to 1. So this is going to factor to be a binomial with those two factors. So it's going to be a minus 9, a plus 3. And this would be considered our final answer here. So quadratics are not too bad to factor, especially if that a value is 1 and you can quick factor. Just be aware, because you can't always quick factor. Now look, in this one, in number 22, is there something in common in all three terms we can factor out? And there is. We pull out an n. So left is n squared plus 10 and plus 16. Now you're going to look inside your parentheses. Can that factor further? Well, it's quadratic, so we'll try it. Well, multiplies to be 16 and adds up to be 10. 8 times 2. 8 plus 2. So our factors are positive 8 and positive 2. Now we can quick factor because that a value is a 1. So we know this can factor to be a binomial with those two things. So it's going to be n plus 8 and n plus 2. But do not forget about that n you factored out in the beginning. So we also have an n in that part in our answer, in the front of our answer. Okay, so that would be our final answer for that one. For this next part, it's literally as easy as it looks. 48 squared is 48 times 48, which is 2,304. You'll just type it into your calculator. 31 squared is 31 times 31, which is 961. And 29 squared is 29 times 29, which is 841. You'll just use your calculator, type it in. Those are literally as easy as it gets. Like, you really just type it into your calculator. All right, with these, we're just finding the product, so we know how to do that. We're going to double distribute. V squared is, V times V is V squared. V times negative 7 is negative 7V. Positive 7 times V is plus 7V. And then positive 7 times negative 7 is negative 49. Combine like terms, V squared, and then these middle terms add up to be 0, so they go away. Now that won't always happen, so just be really careful. But in this case, it did happen. So we have V squared minus 49. And this would be our final answer. Looking at this, we're going to double distribute. V squared, draw your rainbow, don't miss anything. V times V is V squared. V times negative 2 is negative 2V. 2 times V is positive 2V. And then positive 2 times negative 2, don't make any sign errors. It's negative 4. Combine like terms. V squared, our middle terms add up to be 0. It just happened to be that way this time. It won't always happen. And then minus 4. So careful here. Same thing though. Double distribute. 5 times 5 is 25. 5 times negative g is negative 5g's. Positive g times 5 is positive 5g's. And then positive g times negative g is negative g squared. So then from there, you'll combine like terms, 25. And then these happen to add up to be 0. And then we have minus g squared. Now if we write this in standard form, that's negative g squared plus 25. It was positive 25 minus g squared. So if we rewrite it like this would probably be even more correct, writing it like this. Negative g squared, and it was positive 25, so plus 25. So Okay, with this one, we know we can't just square this. That'd be breaking the forbidden rule. So we'll rewrite it as m plus 4n times m plus 4n. And then we're going to double distribute using properties of exponents and being very careful. M times m is m squared. M times positive 4n is positive 4mn. Positive 4n times n is simply positive 4mn. And then positive 4n times positive 4n is positive 16n squared. So then from there, combine like terms. We have an m squared, no other m squares. Those add up to be 8nm's. Remember, you don't add your exponents here. We're adding like terms. So 4 apples plus 4 apples is 8 apples. The apple part stays the same. So we have 8mm's plus 16n squareds. And this would be our final answer. So same thing with this one. We'll rewrite it as 6x minus t times 6x minus t. Then we'll double distribute very carefully. 6x times 6s is 36s squared. 6s times negative t is negative 6st's. Negative t times 6x is negative 6st's. And careful, negative t times negative t is positive t squared. So then from there, we combine like terms. We have 36s squareds, no other s squareds, and then negative 6st's minus 6st's is negative 12st's. Remember that that's just like negative 6 apples minus 6 more apples is negative 12 apples. The apples part doesn't change. And then plus t squared. So this would be our final answer here. So looking at this next one, a little bit trickier. It just throws people off. So we have s plus 7t squared times s plus 7t squared. We're going to double distribute these properties of exponents when we can. S times s we know is s squared. Careful on this next part. S times 7t squared is positive 7st squared. You can't combine an s and a t squared. So it's just s times t squared. And then we have 7t squared times s, which is another positive 7st squared. Positive 7t times positive 7t is positive 49, and then when you multiply the same base, and they're both t's, you add your exponents, so t to the 4th. So then from there, we'll go ahead and combine like terms. Right here, look at those apple parts. So 7 apples plus 7 apples is 14 apples. Be really careful with that piece, but we'll get there. So we have s squared still, and then we have plus 14 apples. The apples part doesn't change. So we have 14 st squared. We're just adding. We're not multiplying. If we were multiplying, we would add our exponents, but we're adding. We're combining like terms. So we have 14 st squared plus 49t to the 4th. So this would be our final answer on that one. So on 32, we're given the formula for volume. It says volume is equal to 4/3 pi r cubed gives us the volume of a sphere. So they give us the formula for volume with radius r. So we know r stands for radius. Find the volume of a sphere with the radius of x plus 9. So notice how I wrote r is equal to x plus 9. It's because our radius was given to us is x plus 9. Now it says write your answer in standard form. So we're just going to plug it in. So we have volumes equal to 4 pi times by our radius, which is x plus 9, and that's cubed. Now once again, notice I just substituted in our radius because we were given the radius was equal to x plus 9. So instead of an r, I'm putting in what r is equal to, and that's x plus 9 cubed. Now from there, I'm going to write this as 4 pi times x plus 9 times x plus 9 times x plus 9. Because we know it'd be breaking the forbidden rule to just think we could cube this. So then from there, the best way to do this is to actually multiply 2 of them together first. So I'm going to just ignore this for a minute, ignore this for a minute, and I'm going to focus on this piece and distribute that term. So x times x is x squared, x times positive 9 is positive 9x, 9 times x is positive 9x, 9 times 9 is positive 81. I'm going to combine like terms on this, x squared plus 18x plus 81. Now from here, I'm going to multiply in this piece. So I'm still ignoring this piece, but I'm going to take this x plus 9, and now I'm going to multiply that in. So I'm just multiplying this all together piece by piece. X times x squared is x cubed, x times positive 18x is positive 18x squared. X times 81 is positive 81x. And then I've got to distribute my 9 through. So 9 times x squared is plus 9x squared. 9 times 18x is 162x, so plus 162x. And then 9 times 81, 18. Holy cow. 18. Okay, just a second. I might mess up. 9 times 18. So 9 times 18 is 162. Yeah, that's good. So we have 9 times 18x is 162x. And then we have 9 times 81. So 9 times 81. And that's 729. So plus 729. Now don't forget to combine like terms. So we have all this stuff. I'm going to combine like terms. So we have an x cubed, no other x cubes. So I just took care of that. 18x squared, no other x squareds. So I have plus 18x squareds. I'm so sorry. I apologize. I'm looking back at this. When I was distributing this 9 through, 9 times x squared is 9x squared. I did not write that squared. So I hope I didn't throw too many of you off. 9 times 18x is 162x, so I got that piece good. And then 9 times 81 is 729. So I'm combining like terms. So I have x cubed, no other x cubes. But then I have 9x squared plus 18x squared, which is 27x squared here. So we're continuing. So I just combined those. So we have plus 27x squared. Then I'm combining my x's, so I have 81x plus 62x plus 162x is 243x. So plus 243x's. And then we have our plus 729. So then from there, we have this 4 pi. We can't forget to multiply through to all of this. So we're multiplying 4 pi. Well, I just really royally screwed up. That's 4/3 pi, 4/3 pi. So we have 4/3 pi times all this stuff. So now what you're going to do is you're just going to distribute that 4 pi thirds through to every single term. And it's actually going to come out prettier than you think. So 4 pi thirds times x cubed is simply, so this first distribute is 4 pi thirds x cubed. That piece doesn't change. But now you'll do 27 times 4/3 pi x squared. So you'll take 27 times it by 4/3. If you do that, you get 36. So that becomes 36, and then we still have our pi, so pi x squared. Then plus, we have 243 times 4/3 pi. But we want to leave pi as pi because that's prettier, so you're simply going to take 243 and multiply it to 4/3, so 4/3. And you get 324. So we have plus 324 pi x's. And then 729 times 4/3, and that will be 972. So plus 972 pi. And that would be our final answer. So that was quite a hefty problem there. Now they write pi as pi because pi is a lot prettier and it's exact versus the decimal. If you won't type pi into your calculator, just leave pi as pi. Okay, we've got to be very careful with these ones. So because there's a bunch of subtraction in here. So we have 11 and minus 4 minus all that stuff. So be careful here because technically we have a -1 right here in front, and we've got to distribute that -1 through. So -1 times 5n is -5n, and then -1 times +2 is -2. So technically we're doing 11n minus 4, and then we have -5n minus 2. So with that negative, we've got to distribute it through. So now we can combine like terms. Now we add straight down. 11n's minus 5n's is +6n's. And then -4 minus 2 is -6. And now we're going to name it. So we have simplified it. There's our answer. And now we're going to name it. So because it's degree 1, the highest degree is 1, that makes it linear. So it's a linear, and there's 2 terms. So it's a binomial. And then in the next one, we have 7x to the fourth plus 9 minus all that stuff. Once again, don't forget, there's technically a negative 1 out front, and we've got to distribute that negative 1 through. So technically, we have negative 8x to the fourth and minus 2. Very careful here. So we have 7x to the fourth plus 9, and then we're subtracting 8x to the fourth, subtracting 2. Now we can add straight down. Negative 1x to the fourth, so I'm going to write negative x to the fourth. And then we have, so I just added up those, that's negative 1x to the fourth, and then 9 minus 2 is plus 7. So we're going to name it now, and we look at the highest degree. The highest degree is 4, so it would be a quartic. So it's a quartic, 4 quarts in a gallon, quartic, and there's 2 terms, so it's a quartic binomial. All right, with this next one, that's like having a negative 1, we've got to distribute it through. Negative 2d squared, positive 7d, and negative 6. So what we really had was 3d squared plus 8d minus 2, and then we had minus 2d squareds plus 7d's minus 6. And now we can add straight down, now that I've distributed my negative through. So we add straight down, we get 1d squareds, and then we get plus 15d's, and we get minus 8. And now we name it, and we always name it by the highest degree. So the highest degree is 2, so it is quadratic. So it's quadratic because the highest degree is 2. And there's 3 terms. 1, 2, 3. So it's a quadratic trinomial. So make sure you can name a polynomial. Okay, with this one, we're combining like terms. We're simplifying, writing in standard form, and then classifying the polynomial. So the first thing we got to do is combine like terms. Now we have an addition sign in here, so we're just adding. We don't have to do any sign changes here. So we're just simply combining like terms, starting with our highest degree. So I always cross them out as I go. We have a negative 4s cubes, no other s cubes. So we have negative 4s cubes. Now my next thing after 3 is 2, so I look for s squareds. We have minus 2s squareds, no other s squareds. Then we have positive 2 s's plus 1s, which is positive 3 s's. We're just combining like terms. And then negative 3 plus 7 is plus 4. So we have this in standard form, highest degree to lowest degree, and then we have all like terms combined. So now we can name it. The highest degree is 3, and there's 1, 2, 3, 4 terms. So we name it first by its highest degree, and it's 3, so it's cubic. And it's a polynomial of 4 terms. Since there's 4 terms, it's a cubic poly of 4 terms. Okay, moving on to this next one, we've got to be careful. Remember, if there's a subtraction sign, and there is, we have got to be very careful. So we rewrite that as negative 1, and we distribute it through. So we're going to have negative 5d cubed, we're going to have negative 3d, and we're going to have positive 4. You must distribute that negative through. And now that I have distributed my negative through, I can just drop down these front things. Here. So, and then combine like terms. So we have 6d minus 10d cubed plus 3d squareds. Okay, so let's combine like terms. I owe 3d squareds. I wrote cubed, but it's squared. Okay. Combine like terms from here. Starting with the highest, I have negative 10d cubes minus 5d cubes, which is negative 15d cubes. So I'm going to cross them out as I go. And then I have positive 3d squareds and no other d squareds. So plus 3d squareds. And then I have positive 6d's minus 3d's, which is positive 3d's. And then I have my plus 4. So I've combined like terms. It's in standard form. I name it by highest degree and then number of terms. So this one also is a cubic polynomial of 4 terms. Cubic poly of 4 terms. Okay, that should do it.